Welcome all. In this particular video, I am going to explain about the divergence. Divergence of a vector field. Many students feel difficult to understand this divergence, that particularly very useful in mathematical physics. So it's fully about the operation on divergence operation. So what is this operation is going to do, or what is the meaning of this divergence in physics? Divergence, actually it is amount of spreading of a vector. It is a amount of spreading of a vector from a point. See, this is a point. This is a point. So what is divergence? It's the amount of spreading out of a vector from a point. So see here, like this. This is actually divergence. So in physics, what about this vector? Mainly this E, that is electric field. Electric field is always originated from positive charges. The positive charge is a point. So it's the amount of spreading out of a vector from a point. Here E is a vector, electric field vector, electric field intensity. So electric field is normally is pointing out if the charge is positive. So from a point charge, the electric field spreading is actually divergence. Okay, this is one example, and this is one definition about the divergence. Then the another divergence, the second one is, its divergence means that is a change in the density of fluids. Fluids means it may be water or gases. A density of fluid flowing according to a given vector. So for example, that is in case of water. That is water flowing like this. It's spreading out. So you consider one point. This is one point. Maybe this water, this is a streamline flow. If this unstream, that is turbulent one, it may be like this extended. So this is also divergence. So this second sense, second detail or explain about this divergence. Now we move to the third one, the convenient one to express about the divergence. So generally it's divergence nothing but spreading out from a point, spreading out of a vector from a point. Vector means it's a specific direction, maybe x, y, z direction. Then the divergence of vector f. So for example, f is one vector. So it's the divergence of a vector field f. F may be a force, electric force. In case of charges, electric force. That's also you can express it in terms of divergence. The divergence of a vector f at a point P. That's suppose this is a point P. This is a force. Divergence of the vector f at a point P is also defined as a change of. It's a change of vector. Change of vector means vector nothing but this vector, field vector or force vector. Change of vector, expansion. Here it is expansion. From this point to expanded. So expansion. Expansion, that is so defined as change of vector per unit volume. Change of vector per unit volume. That time shrink to zero its volume The point, see here, so when you are spreading out, here the volumes increases. When you are considering this point, that point volume is shrink to be zero. That is shrink to be zero. The point P, whose volume is shrink to be zero, but the extension, when you are moving away from the point, when we are moving away from the point, volume increases. But you are considering this point, the volume shrink to be zero, considering the other. So what about the third point of view about this divergence? Is nothing but it's divergence of a vector f at a point P is defined as the change of vector. The change of vector. Vector here is a field expand. That is in terms of expansion per unit volume of this surface. Okay, as the volume of the point shrink to zero, this point, consider point, where the vector field is originated, that points to be shrink, by the point shrink to be zero. But the field is going to be increases, field volume is going to be increases. That is another one explanation about this divergence. Then the real-time example of this divergence is very simple. How to explain, how to remember this divergence with the real-time examples. So for that, the first example is when a couple split. So a couple, a couple split up and move away from one another. So couple is a positive force, negative force, that is also couple. It's in a real life the one gen and male and female couple. When a couple split up, so this is here couple is joined together. Is when a couple split up and moving away from one another or each other. This is actually divergence. This is a divergence. So what's the example? It's a real-time example. So it's a couple split up and move away from one another. This is an example of divergence. It's not physics, it's a real-time example. Then in another, a teenager whose age which is changes gradually, so it's from the young stage to adult. The young stage to adult, that changes, spreading out, their life spreading out from the young stage to adult. This is a real-time example of the divergence. Then further example, that is when your political that means views, political views this completely is away from what the party you are familiar or what party you belong to. Suppose you belong to one particular party. As time goes on, the party particular some decision and some agenda which is not relevant to our idea, so that we are moving from that party ideology. That is a divergence. That's also divergence. So these are the real-time examples of a divergence. Now we come to the physics once again. How this divergence is going to be explained further. So in case of this, so see here this positive charge, where this electric field is pointing out, that is a positive divergence. Divergence is divergence is positive. Divergence is positive. Okay, positive one. Positive means is moving out. Then if, so for example, that means in terms of that is liquid is flowing out. that is positive. If this particular function is positive, the fluid is continuously flowing away. In case of fluid, it is flowing away. Here in case of charge, the electric field is flowing outside. If this negative charge, then the field is towards this. Anyway, towards or away. This particular one is a point, but the other place it is a high one, that is divergence part. If this particular charge Q is a positive, this part electric field is comes out, that is flowing out. If it is negative, the same time the electric field is all moving towards the particular point. Anyway, the point is very small part. Then other one is comparatively higher. This is all about this example and relevant explanation of this divergence. Now we move to the example ones. Now the real-time example and the physics related example also studied. Now the exact definition of this spreading out, that's all. Okay. Divergence of flux, that is divergence of flux velocity at a point represented by the quantity of fluids flowing out per second per unit volume enclosed by a closed surface surrounding that point. Once again, what's the definition? Divergence of flux density at a point is represented by the quantity of fluids flowing out per second per unit volume. Fluids mean here I am talking about the water, that's all. Okay, so divergence in case of the water that is coming out from the tube with the velocity v, that means divergence of flux velocity v. Flux means what? Flux means number of, in case of electric field it is number of electric field lines. In case of that means fluids, the number of that means fluid lines. So you know that in the streamline flow there is number of layers. So all that liquid layers are not the same velocity, having different velocity, you know that. This is about the fluids. So the divergence of fluids V is nothing but the quantity or the flux which is comes out. The flux of the fluid is fluid flux, that means V comes out per second per unit volume of a given closed surface. Here closed surface is a pipe, within the pipe volume. So that is actually divergence. Now we move to the representation of divergence. How to represent the divergence? Actually symbolical representation of divergence. So for example, suppose one function is there, v, that is v of x comma y comma z, that means in 3 dimension. Suppose this value is x, y, and also this is y squared minus x squared. Then how to find this divergence? Divergence of v of x, y, z. What is the meaning of this x, y, z? This velocity which have the 3 coordinate axis x, y, z, like that. So if you are finding divergence of v, it is better to write like this. Divergence of v of x, y, z, that is into that is equal to dou by dou x, dou by dou y, dou by dou z into this term. This together we taken as p of x comma y, and here it is q of x comma y. Here 2 quantities given, so two dimensional enough. Three quantities given means you can write three quantities. So this is a vector, fluid's vector, whose velocity along x and y axis is represented by xy is in the matrix form xy and y squared minus x squared. This can be rewrite like this. Divergence, when you are taking divergence, div v of xy is equal to dou by dou x, dou by dou y, and this xy is taken as p of xy. This taken as word p of xy. This is word q. This quantity is taken as p, this quantity is taken as y. Now you can find out this divergence. So this that is dou p by dou x plus dou q by dou y. Then what is the answer? Dou p is actually xy. Then xy means then the differentiation of this xy actually, that is with respect to x only, so that dou by dou x of xy plus dou by dou y of y squared minus x squared, that is equal to y plus this is 2y, so that is 3y. So this is actually the mathematical expression. It's a mathematical expression about this divergence. How to find the divergence of this fluid velocity v. Fluid velocity means velocity of the liquid in x and y direction in two dimension. Suppose the fluid velocity is represented by v of x comma y, the quantity in terms of matrix means whose divergence is taken by this way. Divergence of v of xy is equal to write like this form, and that means this p of xy nothing but this quantity, q of this quantity the second quantity, and you are taking divergence dou p by dou x, dou q by dou y. So p here it is nothing but xy, q is nothing but y squared minus. So after taking the differentiation, this is 3y. So divergence of the fluid velocity v of x comma y for a given fluid under this two dimensional motion is actually value is y plus 2y, that is 3y. Now we move to the another example. So how to find the divergence of the values, that in mathematical or numerical examples. So move to the next part. So the next part is that expression is for finding the divergence of. So what about the divergence of a quantity, that is f of divergence of f of x comma y comma, that is in three dimensions, x comma y comma z is equal to, that is going to be find out here. F of x comma y or f of x comma y comma z is given, that value is actually 2xi plus 2yj plus 2zk. Okay. So f of x, so the one quantity is given, f of x comma y comma z, this is a function in three dimensional variation, 2xi, there I is a representation that is along x-axis, y-axis and z-axis, y-axis, j, z. So now we are going to, this is a function whose divergence is going to be find out. Now divergence of field, that means field vector f is equal to, already know that dou by dou x of this 2x plus dou by dou y of this 2y plus dou by dou z of 2z. Already I explained why they like that. So this 2x is taken as p, 2y is taken as q, and 2z is taken as r. The previous theoretical explanation I told clearly, that is dou by dou x, dou by dou y, dou by dou z, and that next one is p, q, r. So dou by dou x for that function p, dou by dou y for that q, and dou by dou z for r. So like that here p, q, r. So what about the differentiation? This is actually the differentiation of this 2x, that is 2. Here it is 2. So this is answer. So the divergence of field vector F value, that is 2xi plus 2yj plus 2zk value is, the final answer is what, 6. This is actually example how to find. Then finally I am going to explain one further explanation about the symbolical representation for this current density and also the charge density. Current density J and charge density rho. These two is going to be expressed in terms of divergence. So divergence of current. Current density means what? J. This is current density. What is mean by current density? Current density nothing but current per area. Current per unit area. Then charge density, the charge amount of charge flowing. That means rho, charge density. So charge density and current density is how these two are going to be related in terms of this divergence and H. So actually this divergence of J, that is current density whose divergence is equal to minus dou rho by dou T. This current charge density. There is a interlink, that is current and also charge. So current density is equal to charge density, like that means del dot z means J is equal to minus dou rho by dou T. Actually this is a scalar, this is a very important point. After taking the divergence of vector, it is a scalar. A divergence of vector is a scalar. A divergence of vector is a scalar. See here, divergence of vector is a scalar. So when you are taking this delta J, that means plus dou rho by dou T is equal to 0. This is a equation we know familiarly, continuity equation. So continuity equation in this particular divergence point of view. So divergence of current density J at a point is numerically equal to the quantity of electric charges flowing out per second. Flowing out per second in a closed surface surrounding in that particular point. That is actually meaning. So this all about the explanation of divergence. Now I hope that these explanations are enough to get an idea about the divergence. So divergence is not a very difficult and it's not a tough portion. It's a very easy and you are seeing like this. So by this I conclude this video. We'll meet in the next video. Thank you.